Lesson 25, Quadratic Functions. In this lesson, we're going to talk about standard form and vertex form of quadratics and how to graph them. So, standard form, remind yourself, is y is equal to ax squared plus bx plus c. And if we ask vertex form of a quadratic, then it would be y equals a times the quantity of x minus h squared plus k. If you were given a question that said convert f of x, which is equal to 2x squared plus 3x minus 2 into vertex form, what you would need to know is that we're going to try to complete the square. So, reminders about completing the square. When we want to complete the square, we have to make sure that a value is equal to 1, and we typically move the c to the other side. So, those are two things that we like to do with completing the square. So in this case, I have a negative 2 as my c value, so I'm going to move that to the other side by adding 2. So I'm going to start with saying I have f of x plus 2 is equal to 2x squared plus 3x. The next thing, so I've checked off the first box. The next thing I need to do is make sure the a value of the completing the square side or the squared side is 1. Well, to do that, we're going to have to factor a 2 out of both terms on the right side. So we're going to have f of x plus 2 is equal to 2 times x squared plus 3 halves x. And that's going to be how we can complete the square. Next, because we factored this 2 out and we're going to add a plus blank on the right-hand side, we need to make sure when we are on the left-hand side, remember whatever you do to one side, you do to the other, we also do 2 times plus blank. So the next step is we're going to write the plus blanks. So f of x plus 2 times blank is equal to 2 times x squared plus 3 halves x plus blank. Notice this 2 times the blank and this 2 times the blank are now equal statements. I can do one thing to the other side. Everything I've done to the left, I've done to the right. Now, how do we complete the square? Remember, we take this b value, 3 halves, and we divide it by 2. Now that's weird. It's a fraction on a fraction, so I'm going to change, flip, keep the first fraction, change the symbol, flip the statement, so we actually get this. And then remember, our goal is to square that statement. So that's going to be 3/4, and when you square for 3/4, you get 9/16. So we're going to add 9/16 to both sides. From here, we're now going to factor the trinomial. So we're going to factor the 3-termed part here so that it can be written as something quantity squared, because we know it's a perfect square trinomial. So on the left, I still have f of x plus, now I'm going to change 2 in terms of 16ths, this 2 here. I'm going to change that in terms of something divided by 16. That's going to be 32 over 16. Plus, now I'm going to multiply this. I got 18 over 16. That's going to equal 2 times the quantity of something squared. That's going to be x plus 3/4. From here, the vertex form says that I have y equals so on and so forth. So now I need to take that 32 over 16 and that 18 over 16, combine them, and then move them to the other side. So I'm going to take these 2 terms here, add them up, and I'm going to get f of x is equal to 2 times the quantity of x plus 3/4 squared minus, now 32 plus 18 is going to be 50 over 16. But I can simplify that fraction, right? That fraction is simplified because I can divide both terms by 2. So we have 25 over 8. So, things that could be asked of you once you have this form. 1, what's the vertex? Well, the vertex is the h and k value, so we would have negative 3/4, 25/8, negative. Then it might say, give me a sketch. Well, we know negative x and negative y are going to be living in quadrant 3, so I'm going to draw my graph geared towards quadrant 3. I'm going to think about the fact that it's a sketch, not a graph. So we have -3/4, -25/8. So something around there. If you label it, you're good. -3/4, -25/8. And then I look at my a value. It's +2, so I'm going up. And then things to think about in my standard form equation. So looking at the very top, if I were to do f of 0, I would get 2 times 0 squared plus 3 times 0 minus 2. So we get this number of -2. That's your y-intercept. So I could graph that at -2. And then my parabola, again, is going to be an upward-facing parabola, like that. And that's a sketch. Okay, let's move on. So on this slide, you might want to freeze this to write all of it down. You might notice on the graph, we have a downward-facing parabola with 2 solutions at x1 and x2. We have a y-intercept at a green dot. That green dot is known as the c value. So if I was given standard form, it'd be 0, the c value. If I was given vertex form, I'd have to plug 0 in and find the y value. The purple dot on the graph is known as our vertex, our h and k. If we're given vertex form, it's really easy to identify. If we're given standard form, there's ways to do it. You can do -b divided by 2a. That's going to be your axis of symmetry. And then to find the actual y value, you plug in that x value to evaluate the y. In terms of your axis of symmetry, that's your dotted blue line. That's going to be x is equal to h. It's a formula. Or you can say x is equal to -b over 2a. These are formulas you're going to want to know because they're very helpful. In terms of the y-intercepts, again, it's 0, y if you're vertex form, or 0, c if you're standard form. In terms of your x-intercepts, root zeros, or solutions, you'd write your x-intercepts if they asked you for an x-intercept as a coordinate. So you'd have x1, 0, x2, 0. Or if they asked you for a solution, you would use set notation x1, x2. Domain for all graphs, unless we're talking real-world problems for parabolas, are going to be all real numbers. In this case, for this example, my range is going to be y is less than or equal to that k value, the maximum value. And then on the left, underneath the graphs, you'll notice that there's function form, standard form, vertex form, and factored form. Let's move forward. So imagine I asked you to graph f of x, which is -2x plus 3 quantity squared plus 4. So this is going to ask a lot of us in this example. We're asked for the vertex, axis of symmetry, domain and range, the zeros, the y-intercept, how its concavity is, if it's up or down, the maximum of the value of the max or minimum, and then we're going to have to convert this vertex form to standard form. So, things to notice. First and foremost, they gave you a vertex form equation. So we need to know that this is vertex form. Since they gave us vertex form, that means that the a value is equal to -2. We know h is equal to -3, and we know k is equal to 4. Because we know the vertex, we should put that on the middle of our chart, our table, and then we should build around it. So we can go -4, -5, -2, -1, and I'm also going to go to 0 since I see that I have to calculate the y-intercept on part F. In terms of calculating it, things to remember, quadratics are symmetrical, so whatever happens at -4 for the x also happens at -2, and whatever happens at -5 for the x also happens at -1. Things to just remember. Now, we do know the vertex. The vertex is at -3, 4, so we can graph that, -3, +4. And then we also know the axis of symmetry because the axis of symmetry is the x value of the vertex. So we could graph that dotted line at x is equal to -3. Remember, put an arrow on both ends, label it x equals -3, and your axis of symmetry equation is x equals -3. in terms of our domain, domains for all quadratics are going to be real numbers. And then, well, let's calculate what else we have to graph. So if we were to plug in -2 into our function, do some work over here off on the side, f of -2 is -2 times -2 plus 3 is going to be 1 squared, and I add 4 to that. Well, it's going to be 1 squared is 1 times -2 is -2 plus 4, which gives us a value of 2. So whenever I get -2, I also have the value of -4, and I can graph that. From there, I'm going to plug in f of 1, -1 I mean. So that's going to be -2 times -1 squared, well, not -1 squared, -1 plus 3, which is going to be 2 squared plus 4. So then I do 2 squared, which is 4. 4 times -2 is -8. I add 4 to that, and that's going to give me the value of -4. So when x is -1, I have -4. And when x is -5, I have -4. So I'm going to graph those values. And then, because I have 2 dots on each side of my vertex and then my vertex, I'm going to graph my parabola. So my parabola is just going to be graphed like that with arrows on both ends of my parabola. Again, because I know I need the y-intercept in part f, I'm going to plug in f of 0 just to go and get a number there. So we have -2 times 3 squared plus 4. 3 squared is 9. 9 times -2 is -18. I'm adding 4 to that. So my y-intercept is going to be 0, -14. Obviously not something I'm going to graph. It's off my graph, but it is something I do need to calculate. Okay, in the meantime, the next question says, what is the range? So if I look at my graph, I notice my graph's going downward. So I could say -infinity all the way up until the y value of 4. Or I could say y is less than or equal to 4. Either one work for me. Unless you're asked for interval notation, then you would need the first one. Next, part E says find the zeros. So we're going to set the equation equal to 0 and then solve for the x. So we have 0 is equal to -2 times x plus 3 squared plus 4. So first step, we're going to move the 4 over and then divide by -2. So when we subtract 4 and then divide by -2, we're going to be left with 2 is equal to x plus 3 squared. Again, if you don't know how I got 2, I'll backtrack a little and I'll show that step. So we had -4 is equal to -2 times x plus 3 squared. Divide both sides by -2, we're going to get 2 equals x plus 3 squared. From there, square root both sides. Remember what goes in front of a square root is plus or minus. So we have plus or minus the square root of 2 equals x plus 3. From there, isolate the x. So you get something like x is equal to -3 plus or minus the square root of 2. Final answer in set notation, -3 plus or minus the square root of 2. Then it asks you about concavity. Is this shape concave up, pointing upward, going to a positive infinity, or is it going down to negative infinity? In this case, we're going down, so we got that one. And then what is the value of the maximum? So what is the maximum y value that this graph has? That's 4. Okay, part I wants us to take this vertex form equation and convert it to standard form. So remind yourself, what is a standard form equation? So we were given vertex form, that's what's here. The standard form equation is y is equal to ax squared plus bx plus c. So what we want to do is we want to expand that x plus 3 squared. So I'm going to start with saying -2 times x plus 3 times x plus 3, and then plus 4. If you know what this x plus 3 times x plus 3 is, it is a perfect square trinomial, so I'm going to expand that to that statement. X squared plus 6x plus 9 plus 4. Next, I have to realize that that negative 2 is a distributor. So I'm going to distribute that negative 2 all the way through. We're going to get something like negative 2x squared minus 12x minus 18 plus 4. And then from here, we have combined like terms. So negative 2x squared minus 12x minus 14, and that's your standard form equation. Notice they don't say factor it. They don't want you to take out the GCF of 2. That's not what they're asking. They just want you to leave it in standard form. Things to know about standard form. So remember, if we were given a standard form equation, you get the y-intercept super fast. The y-intercept is 0, c. So in this case, we would say that this answer is going to be 0, negative 14. You can calculate the axis of symmetry quite easily. You just need to know the formula to do that. That's going to be x equals negative b divided by 2a. If I were to plug that into what I have negative 12 divided by 2 times negative 2. That's going to be a positive 12 on the top divided by negative 4 on the bottom. So I have 12 divided by negative 4, and when I get that value, I should get negative 3. Now, I like that I got x equals negative 3 because that is what the vertex's x value is. Again, if I go to the top here, remember this is my vertex form, and the vertex was negative 3, positive 4. So, in my standard forms, now that I have the axis of symmetry, if I plugged in f of negative 3, well, what would I get? I would get negative 2 times negative 3 squared minus 12 times negative 3 minus 14. PEMDAS matters, so exponents come first. Negative 3 squared is 9. 9 times negative 2 is going to be that negative 18. Plus, now I have 12 times 3, which is 36, but I'm minusing 14 from that. That's going to give me the value of positive 4. Okay, things to know, right? I had a standard form equation, but I was able to find the vertex. It's negative 3, 4, which is what I started with, so we're good. Second to last example. Okay, here we go. So you might be given a question called the vertex and a point. They give you the vertex and a point, and they want you to write the vertex form of the question. Well, you might think that's super easy because they gave you the vertex, but they didn't necessarily tell you the amplitude of it, the a value. So when you're given a vertex, things you should know, right? That 1 is representing the h value. So we know h is 1, and we know k is negative 2. So if you think about it, if I were to use my vertex form as a formula, I have h and I have k. They also gave us a point, right? And points typically are in the order of x comma y. So that means that it gave me an x value of 3 on the graph and a y value of 6 on the graph. So again, if I think about it in terms of a checklist, I have the y value and I have the x value. So what I'm looking for, what I do not have, is the a value. The goal of this question is to solve for a. So how do you do that? Plug in what you have. We had y is 6, so we plug in 6 equals, we don't have a, that's what we're looking for. We do have x, it was 3 minus, we do have h, that's 1. We're going to square that. And then we're going to minus 2 because that's the k. Now, PEMDAS matters. My goal is to get a by itself. So I'm going to isolate the a by first adding 2 to both sides. So I get this number called 8 is equal to a times. Now I'm going to simplify what's in my parenthesis set. 3 minus 1 is 2. Then I'm asked to square this. So I have 8 is equal to a times 4. But how do I get rid of multiplication? Divide. So I have 8 divided by 4 is 2. 2 equals a. Final answer, let's go back to the question. Y equals 2 times x minus 1 squared minus 2. That is our vertex form of this question. Okay, last but not least, you might get a question that's in standard form that looks like this, and they want you to go to vertex form. So we're going to realize this is my standard form, and we got to convert it to vertex. What does a vertex form look like again? Y is equal to a times x minus h squared plus k. Means we have to complete the square. So first things first, remember with completing the square, there's two big rules. C goes to the other side. And 2, we're going to factor a to equal 1. Okay, so I might have something like h of x is equal to h of x. Nope, we're going to add 7/4 because we're moving the c value. Equals 1/2 times x squared plus 3. Next, that was step 1. We moved c to the other side. Next, we have to factor out the a value so we get a 1. So I'm going to write h of x plus 7/4. Because I'm factoring out that 1/2, I'm going to write plus 1/2 times blank. And then I'm going to write equals. Factor out that 1/2. Then I have x squared plus, if I factor 1/2 from that, I'm left with 6, right? Because 1/2 of 6 is 3. So I have 3, oops, that's supposed to have an x there, 3x. And then I have plus blank. Notice my purple statements are equivalent. I have 1/2 times blank and then 1/2 times blank. From here, now, again, this 6 might be hard for us to understand. So if I think about it, I'm going to multiply that back in. 1/2 of 6 is equal to 3. So I had to think it got bigger because I took half away from 6. And now I get 3 when I go back to this statement. So be cautious, that's a little tricky. Now, how do you complete the square again? You take this b value, you divide it by 2. So we're going to get 3, and then you square it, and that number goes in our blanks. So we have h of x plus 7/4 plus 1/2 times 9 equals 1/2. Remember, 9 goes here in each of those. And then I can factor that trinomial. That trinomial is going to factor to x plus 3, if I'm not mistaken, because it's a positive, right? So we got that. Now from there, I'm going to think about how can I combine these like terms. Well, first off, 1/2 of 9 is going to be 9/2. So I'm going to rewrite this as 9 over 2. But I have to combine it with fourths, so I might want to rethink that and say, isn't that equal to 18 over 4? Multiply both by 2 over 2. And then I got to move 18 plus 7. So 18 plus 7 is going to be 25/4. So I'm going to have h of x is equal to 1/2 of x plus 3 squared minus 25/4. That's going to be this example. Now, from here, things that we could conclude, right? What could we conclude from this? Well, first, we could sketch it, knowing that we're going to be at -3, -25/4 is going to be our vertex. Again, how did I know the vertex was that? Because I know the h and k, so the vertex, we'll put it over here, is going to be -3, -25/4. We look at the a value of this vertex form. We're at 1/2. It should be the same a value of our standard form. It is. It's also 1/2. It's positive, therefore that means it's pointing upward. So we have -3, -25/4 somewhere on there. Again, it's a sketch, not a graph. As long as you label the point, you're solid. So we have this statement here, -3, -25/4. We know we're going to go up But what's the solution of this? Like, how would we find the zeros? So let's do that. Let's find the zeros before we graph it. If 0 is equal to 1/2 times x plus 3 squared minus 25/4, first step we would do is add 25/4 to the other side. So we have 25/4 equals 1/2 times x plus 3 squared. Now we got to multiply both sides by 2. So when I take the left side and multiply this by 2, the 1/2 and the 2 are going to cancel. When I take this side and multiply by 2, that's going to be called 25 seconds. From there, we're left with 25 over 2 is equal to x plus 3 squared. You square root both sides. You're left with the plus or minus the square root of 25 over 2, all under the radical. And then that equals x plus 3 minus 3 on both sides, so negative 3 plus or minus, we could call that 5 root 2 over 2 equals x. If you don't know what I did there, I rationalized my denominator. You could practice that. And then last but not least, where can I graph my y-intercept? Well, I know my y-intercept's in the negatives. How do I know that? Well, I go back to my standard form equation. Remember, standard forms give us information. This value is your y-intercept, y value. So we know we're in the negatives down here. We could graph that point at 0, negative 7/4. And then we have something that's going to look like that and like that. And that's it. That would be what we know. Folks, that's the lesson at its finest. Have a great day.